Good morning, developers. Let's start developing. Time for day 3 of our Advent of Code puzzles. Let's see what Santa did today. Hey, the third task is already open, of course. Let's see. Binary diagnostics. Ooh, bit twiddling. That's always fun. The submarine has making noises. We need to run a diagnostic report. Our puzzle input a list of binary numbers. Decoded properly. The first parameter to check is the power consumption. You need to use the binary numbers to generate two new binary numbers, gamma rate, epsilon rate. At least there's not an omicron rate. Multiplying the gamma rate by the epsilon rate. Finding the most common bit in the corresponding position of all numbers. Hey? Let's see the example. Considering only the first bit of each number, there are 5 zeros and 7 ones. Since the most common bit is 1, the first bit is 1. Okay, I guess we won't have any ties. What will happen if we have 6 ones and 6 zeros? So basically we want to run the most common bit and the most common bit and the most common bit on each bit. So the gamma rate is this number, the epsilon rate is calculated. Yeah, we reach the least common bit. Well, this is a complement because we only have 2 bits. If one of them is the most common, the other one is the least common. Then that's about it. Okay, seems like I got it. So I'm quite sure that there is some kind of a binary hack to this. In the sense that if we add them together or if we OR them together or if we do some other kind of magic, that we will able to get this done properly. But I'm not sure, to be honest, and I'm not seeing it directly. So what I do in these cases is I'm gonna implement the naive, so to say, algorithm. So let's create a type that I will call bit, and that will be basically the string 0 or the string 1, because we're working with strings right now. And I will read the lines of the input, and for each line I will map the line into what? Well, we need to split it. Line dot split on an empty string, and that means we have an array, because right now this will return an array of strings. So each thing we are transferring into an array of bits. Since the input cannot know that we only have zeros and ones, I will add that as a type hint. So this means that process input right now produces a prompt of an array of bit arrays, and that will be our input array. So let's plug that in everywhere where we need it. Of course, we can have this part be implicit, but I kind of like it to be explicit, because then it shows me where my error is, where my assumptions are not correct. Let's just result for of what is this input? The report. So this is a diagnostic report and this is a report row, so to say. Let's do something like this. And just log the input to verify that we are parsing it correctly. Row. Now I need this. I need console.log item. Zero zero one zero zero. Yep. The second one is okay, and let's see if we're getting the last one. 1010. Yeah, seems like we got the values. So now for each of the items we will need to do an analysis. So we will need to reduce our input matrix into a single row. So it's not so much of a matrix, it's a collection of diagnostic reports, collection of rows, but that's about the same thing. So we can say I will actually reduce this part into some kind of a counter. So we will have another type, and we can define this in a much better way, but for now, well, I need it to have a key called 0 and a value called number, and a key called 1 and a value that is a number. So we will start with a 0 zeros and 0 ones, and then for each row that we are processing, so the first one is the count, and then we have the row, and we're gonna start with the count. So we will try to reduce our matrix array of bit things to a single array of counts, and each count will have the number of zeros and the numbers of ones in that position. But do I have the correct structure? No. No, we need to start with an array of empty array of count objects. So that is a count, and that is a count array, and we will need to create a new map. Yeah, it needs to have the same amount of values as the input has, so that means that we can just map, we can do an array from or something like that, but this is about just as effective because we're not actually using the value, we just need to initialize it. Or do we need to reduce? Yeah, on the other hand, we don't need to reduce anything. Do we? Yeah, we do. Yeah, we do. Because we're going sideways. not counting for each, we're counting by columns. And another, and right now counts is an array of count object. So now we're starting with the counts, which is an array of count objects, and what we want to do. And this will of course not a bit array. Why are you getting that the current value is not a bit array? So we will need to return, if we just say return count, and this is the wrong implementation, but right now the types are at least correct, so we're returning an array of counts. So for each row, how do we transform the count? Well, we can just do a loop over the row and get the bit value of that specific row. Yeah, this is kind of correct. So the ith item of the row is a bit, and then we have that, so this is either a 0 or a 1, and the count of that bit we can add 1 to it. And now it says we have an error. Operator plus equals cannot be, well, count of bit should be a number. Oh no, count of index of bit is a number, because we have an array of count objects, and each count object has a 1 and a 0 property. So, and that is one that we will need to add +1 to. So we are modifying our count object and we're just returning it over and over again. And I will have this as a, now I'm gonna do it like this. So these are the initial counts and these are the actual counts. I have no idea what I just did. I have a feeling that it should be somewhat okay, but we need to check it. We need to see if this thing actually works. Let's see what we have in the counts array. So we have 5 zeros, 7 ones, 7 zeros. Why are there 11 of these? Because I don't need, I'm getting the correct, the incorrect size. I managed to have as many counts as there are inputs, but I want to have as many counts as there are items within each report. So we can do this actually. Yeah, this, we are making an assumption here that there will be a first element, but we are basically running two use cases and there is always a first element. So that is some kind of a, let's say, invariant or an assertion of a application. So let's see, and this is better. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 items, and each item has the relative frequencies of zeros and ones. And since there are two, now we can write some easily stupid code that calculates the epsilon. The gamma first. And that is actually a bit array. So we need to map the counts. That is an array, so for each count. And we can say something silly like this. If count of 0 is bigger than count of 1, so the gamma was the most common. So if count of 0 is bigger than count of 1, then yeah, the value is 0, otherwise the value is 1. So get the most common thing, and epsilon is literally the same, only the other way around. Of course, we can generate the epsilon by reworking the gamma in a different way. And of course, we can do a join on this with an empty string and a join on this with an empty string. So epsilon and gammas are not a bit arrays, they are strings. And then we can console.log gamma and epsilon. Let's see if we get what we want to get. So we are getting 9 and 22. And we were supposed to get 22 and 9. Yep. Seems that we are correct. Yeah, this is the gamma, this is the epsilon. And now, I know that this is some kind of heresy because I'm using strings to represent bits, and that's extremely wasteful and whatnot. But it works. And it is not that wasteful, to be honest. Because even if we are using bits, most of the time bits will be represented in something like a 64-bit field, so it is wasteful all the time. But what I can do, and I can waste some more cycles in the computer by just, instead of calculating gamma, I'm gonna pass it over to the JavaScript engine, because JavaScript has actually a really nice parsing part. So I can say parseInt, yeah, gamma as a binary number. So this will be G value. And then we can, of course, do that. If you don't believe me, we can see that this actually works. 22 and 9, and now we just need to set up our result, which is actually G value times E value. And we are getting 198, and we were supposed to get 198. Dun, 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 dun. But this is not the important thing. This is kind of the important thing. So right now we have 1,000 of these. Well, the algorithm is more or less linear, so I don't expect it to be slow. 26 milliseconds, nothing. Oh, that's the input. The actual time for processing is 3 milliseconds. So this has a bit of a correct fill. Let's see if that is okay. Ooh, my internet glitched. And that is always, yay! It is correct. We have one gold star. Ooh. And I kinda hate where we have such a large explanation, because it means that right now, more or less, most of the things we did for the first part will just not be relevant for the second part, because we're gonna change what the input means completely. Life support rating, multiply the oxygen generator rating, CO2 scrubber rating. So we need to calculate two more ratings. Finding them is the tricky part. I kind of believe that. Both values are in similar position, filtering out values until one remains. Full list, just the first bit of those numbers. Then, keep only numbers selected by the bit criteria. So I guess we will have, yeah, we have a definition of whatever the bit criteria is. Most common value in the current bit position, and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with the 1 in the position being considered. Least common value. Aha. So, oxygen gain generator writing, and we are using the most common value, preferring 1. Let's see. All 12 numbers consider only the first bit of each number. There are more 1 bits, so we are keeping the 7 numbers that have a 1 bit. Okay. Now we have the second, we need to calculate the second bit of those 7 numbers. 0 bits, 4 bits. We're keeping only these 4 numbers that have a 1 and a 0. So we have 1, 1, 1, 0. We are removing this one. So the fourth bit. So the fourth bit 1, 1, 0. We are losing this one. The fifth bit. Yeah. So the fifth bit we have 1 and 0, and we are favoring the 0, the 1. So we are getting this one. I'm not sure that this will leave us with a single number in the general case, but I'm quite sure that this will leave us with a single number in our case. So let's try this one for size. So we have our inputs. We need to determine basically the most common. I will start doing some helper function. I will do a get count function that will take an array of bits and an index, that is a number, and will return the count for that specific index. So this will go through. Is this it? Yep, this is it. Yeah, thank you GitHub Copilot, because I think this is exactly it, that we are running through the input, and for each item on that specific index we are getting the value. Of course, we could use this right now, this inside our reduce function, and I think we shall. No, no, we shall not, because it will actually make it into a quadratic complexity, more than quadratic complexity. Because for this thing runs through, this thing runs the other way. So the reduce goes line by line, and this goes column by column. So this is useful if you only were interested in a single column. And now I guess that we will be. And of course we will be filtering this thing, so we won't always have the same input. Yeah, so for a given list of status reports, we will get at the count. Actually, why not add another type that might be useful? And we will have the most common, which is a bit, and the least common, which is also a bit. So we can just, instead of returning this of a count, we're returning a histogram. And then we can say there are actually only two possible histograms. And we can define them. Now, that could be a bit of an overkill. So, yeah, this can be done more efficiently, but if we have something like this. So, most needs to favor the ones, because if it is a tie, then it's 1. If we have more zeros than ones, then it is a 0, otherwise it is a 1. So if we have an equal amount of zeros and ones, this will be false and we will get a 1. Yeah, so the list will be just the other way around. If there are an equal amount, this will be a 0. Okay. So we have a method for a given list of commands. We can see which one is the most, which one is the least. So what do we do? How do we get the oxygen generator rating? Let's have it as a separate processing, and then we will merge it somehow. So oxygen. Yeah, that's totally not correct. But what we can do? Yeah, we're gonna make a copy of our input because we don't want to break it. And we can say, while something like this, because this is totally incorrect, but I wanted to have something of this, while the length is bigger than 1, because if the length is bigger than 1, then we are done. And what we want to do? We want to run the report on an index. No, this is not a const, it is let index equals, well, the first bit. So we need to get the count on the array of reports on the position index. Yeah, this is actually a histogram, but I'm gonna call it count. So we need to have the most, and we need to filter the reports. So this is a let, where the row of index is the most of that count. Yep. And of course we need to move the index one position. Let's see what this thing does. Yeah, you can see that I theoretically have an infinite loop, but this kind of finished. So what is the value of reports? The value of reports, ooh, I let it run for the huge input. I didn't want to do that. Right now I have no idea whether this thing actually makes any sense or not. I want to run it for the small input in order to see some kind of a result. It says that is 1 0 1 1 1, and the one we wanted to find is 1 0 1 1 1. And let's see for the oxygen, for the CO2. Yeah, I'll just reuse that. Since the filtering goes the other way, we will definitely need to run it twice independently for each time. And so it makes sense not to reuse the variables, so we could say we will call this O2 reports, and this is an O2 index, and this we have O2 value. So we definitely don't need this, because this just maps something, a string to a number, which maps it to a string. So we have the zeroth item because we know that exists, and we can even cut some slack and do it like this. So this is a CO2 report, this is the CO2 index, this is the CO2 report, this is the CO2, 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 and the CO2 index is the count least, and then we are increasing the CO2 index, and then of course we have exactly that. Let's see if this makes any kind of sense, because we needed to return 230 and we returned 230. Looks correct, and I'm quite sure that we have to run this process twice. Well, we could extract this into a method, but we're only calling it twice. He's making a list, he's calling it twice. So we will need to see the huge input and see if this thing works or if this thing breaks. Since we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If we have more than 12 loops, this thing will run out of bounds, and then we will have some weird results. Hopefully the algorithm finishes. I have no idea, and apparently it did finish. And the moment of truth. Oh, it might be not me. the server is running a bit slow, and I gotten my 6th gold star of the 2021 Advent of Code. Well, this was a bit of a confusing task, and I do have an inkling that for most of at least the first part, we can do some bit twiddling, because I never actually used the fact that these are bits. Yeah, they could have been X's or stones or whatever words, so I didn't do any bit manipulation here. I only did some bit observations, and I'm quite sure that it's possible, at least the first part, to be much faster and much cleaner. But on the other hand, if we run completely out of debug mode, yeah, I'm gonna need to type it in. It is, the total running time is about 5 milliseconds, or 9 including the input, so it's okay. I don't think it's too slow. So, 6 stars done, 44 more to go, and I will leaving you right now. If you want to learn more about TypeScript and all the types that I'm declaring, feel free to check out the TypeScript Workshop, and see you tomorrow.